Hello. My presentation is devoted to an important task of speech recognition. Namely, we extract numbers from the result of speech-to-text conversion for Ukrainian. Human much easier perceive text with numbers, and this text is more compact. Also, numeric context analysis can be done automatically. More numeric types can be processed, durations, currency, etc. And what about dictating your mathematic formula directly to computer instead of typing? Modern models are aimed to minimize supervision and requires huge amount of annotated speech data. For a highly inflective language like Ukrainian, this data amount is and computations are more exhaustive. Besides, some reports state that misleading results for human may be received by these methods. In past, we designed bidirectional text-to-pronunciation conversion, which is rule-based and used for Ukrainian language. Initially, we believed that a reasonable supervision amount would be required for our model training, and here we can see the typical output of a speech-to-text converter. Here is a sequence of words, and each word has estimations for beginning and duration. Moreover, some systems can provide information concerning speaker change. All these estimates are useful to detect utterance bounds. I am selected with blue rectangles hypothetical numeric sequences. There are two such sequences, and you can see one of the words is homograph or homophone, and it's an issue for Ukrainian. Another word, far from numeral, and the right column illustrates what we would like to receive, what we expect to extract from a sequence of words, and numerical words are among them. This slide illustrates how works our text-to-pronunciation multi-decision converter. By the rules, we build a graph, walking through which we can generate different pronunciations for a given word. Like in this example, Ukrainian word snig, meaning snow, can be pronunciated in four slightly different ways. Similar approach can be applied to sequences of numerical words from quite limited sub-vocabulary. By sequences of such words, we can extract sequences of numbers. How can we do this? Let's consider in details. These are the stages that should be performed to complete the task. Firstly, we should spot the numeric text, and then we apply language-dependent conversion mapping to internal representation of spotted word sequences. After that, we detect hypothetical boundaries of numbers. Then each number will be converted from its internal representation to the sequence of numbers. Finally, the numbers will replace words in text. Let's consider what is a language-dependent conversion is. Let us have an example, word sequence 2019, and here is its internal representation, where 2 is mapped to its digit representation and to label, meaning the digit position in the number. 1000 is mapped to a label that means word group termination. Beside 1000, such word group terminators are for millions, billions, etc. 19 is mapped to a pair of digit and label. Another example consists of 2 words, and we convert it to the following internal representation, which is quite apparent now. Here are some illustrations for language-dependent rule specification. Source subsequence specify as many as possible word forms. Step equal to 1 means that we move right to the next word, and target sequence means the label or the digit and label that we map to. Another example is for word 500, which is mapped to digit and label, and 12 is mapped to pair of digit and label. So now we can detect the number boundaries. It's done taking into account valid label sequences. How we convert from internal representation of words to the sequence of numbers. Here is easy, we just remove the labels. However, in this case we should insert missing zeros for digit positions which were skipped while pronouncing. So finally we receive the number just removing all the labels. Now we can extract hypothetical sequences of numbers by the text, and Bayes hypothesis can be selected by analysis of a wider context using a large corpora. New language introductions looks quite not complicated. An expert just need to fill the language-dependent rules that maps numerical words to their internal representation. And future research will allow us to cover more and more numerical types. That's all. Thank you.